Hey everybody, welcome to another con support video. This one is on systems of equations with substitution. So yeah, let's go. See how it goes. All right, so here it says solve the system of equations negative 4x plus 11y equals 15 and x equals 2y. So we're looking for the solution of the system. So we're looking for an x and y order pair that works for both of these linear functions, right? All right, so when we're solving a system like this, there's lots of ways you can do it. This particular one focuses on substitution, and all you're basically going to do is you're going to try to get one of the variables in terms of the other. So you can see in this equation here, I've got x in terms of y, so x equals 2y. It doesn't matter which is in terms of which. So if you get x in terms of y like that, where x is isolated, then you can just plug into the other equations x, right? So what you're going to do is you are going to take this value of x, which happens to be 2y, and you are going to replace x in the other equation with 2y, right? And the idea there is that you're going to find then the y position of the intersection. So that's all you got to do. You just got to substitute the value of 2y in for x, okay? Because technically speaking, the x in both of these should be the same, right? Because you're looking for the order pair that's got the same x, right? That's the same order pair on both lines. So if you can find the value of x in one, that should be the same as the value in x in the other, right? So if you replace this x with the other x, you're good to go, right? So x is equal to 2y, so therefore x is 2y, and we can substitute it just like that. So now let's go through and solve that equation. So what we get there is we're going to get negative 4 times 2y plus 11y is equal to 15. And negative 4 times 2y is going to be negative 8y. So that's negative 8y plus 11y is equal to 15. And then you're going to want to get all the values of y there, right? So what's negative 8y plus 11y? Combine your like terms, you're going to see that that is 3y. So 3y is equal to 15, and then you want to undo times by 3, so divide by 3 both sides of your equation, and you're going to get y is equal to 5. So the solution to this system is going to have a y value of 5, okay? Now, that's the y value, but we still need to find the x value. So we know that we have the y value of 5, but we don't know the x value. Let's find out what the x value is. So to find the x value, just take this y and replace it in either equation to solve. So what I like to do is I like to pick one of these to solve with. So I'm going to solve with this one down here. And then I like the other one to use as my check. So I'm going to check with the one up there. All right. So let's plug in the 5 for y and see what this gives us. So we're going to solve by doing x equals 2 times whatever we think y is. So 2 times 5 is 10. So it looks to us like, or to me, like the answer is going to be the order pair 10, 5. When x is 10, y is 5. We know that exists on the line x equals 2y, but now we need to make sure it also exists on the other line as well. Okay, so that's where the check comes in. So then the next thing I would do is to check to make sure that it works on the other line as well. So here's our order pair that we think is a solution to the system. Let's plug it in and see if we get a true statement. Negative 4 times whatever x is, 10, plus 11 times whatever y is, 5, equals 15. Negative 4 times 10 is negative 40, and 11 times 5 is 55. Is negative 40 plus 55 equal to 15? Yes. So we know that this order pair 10, 5 is a solution to both of these lines and is a point on both of these lines. And that's how you do the problem. All right, here's the next one. All right, so we can see in this one, they give us two linear functions, 10x minus 9y equals 24, and y equals x minus 2. Now, because you have y equals, we know we can use substitution because we already have y by itself. So what is y equal to? X minus 2. Just replace the y in the other equation with that x minus 2. And we'll solve for the x location over the intersection point, right? So that's all you got to do. Just substitute x minus 2 in for y in the other equation, and then we can solve. All right, so let's do it. Let's see what happens. So in this case, we've got 10x minus 9 times the quantity of y, which is x minus 2. And then that's equal to 24. And so now we're going to distribute. So let's distribute that negative 9 through the parentheses. So you get 10x minus 9x plus 18. Because negative 9 times x is negative 9x, and negative 9 times a negative 2 is a positive 18. And that is equal to 24. Then you're going to combine your like terms. So we have a 10x and a negative 9x, which is worth a positive 1x. So you have 1x plus 18 is equal to 24. And then you don't want the value of, you don't want the 18 on the same side as the x. You want to get x by itself. So what is the x worth? We're going to take away that 18. So we're going to take away 18 from both sides. And what is 24 minus 18? So the x must be equal to 24 minus 18, which is 6. All right, so where do these lines cross? Okay, we think that they cross at an ordered pair that has an x value of 6. So we think the x value is 6. Now we need to find the y value that goes with that. So all you're going to do is pick one of these to solve with, the other one to check. So what I'd like to do is I'm going to just do this easy one to solve, and then I'll do this one up here to check. Okay, so we're going to solve with y equals x minus 2. So let's do a little solution here. So we know that y is equal to x, whatever x is, which happens to be 6, and then minus 2. So y must be 4. So we think the answer is 6 comma 4. So we think when x is 6, y is 4. And then we're going to check it, okay, by just plugging it into the other line, because it needs to be a solution not just to one line, but to both, right? Because it's a place of intersection between the two lines. It's where the x and y is the same. So here we got 10 times the value of x, which is 6, minus 9 times the value of y, which is 4, should be equal to 24. Let me fix that. It's a little sloppy looking. Should be equal to 24. And so 10 times 6 is 60. 9 times 4 is 36. So we're going to do 60 take away 26 should be, or 60 take away 36 should be 24. And yeah, 60 take away 36 is 24. So it works. So now we have evidence that it is perfectly correct that this ordered pair exists on both of these lines, this one and this one. So we now can say this is correct. And x is 6, y is 4. All right, let's do the next one. All right, so let's solve using substitution. Once again, you notice that they did provide you with an x equals or a y equals. In this case, they gave you x is equal to negative 3y plus 8. So that means you're just going to take that value of x from one equation, and you're going to replace x in the other equation with that value. So we're going to do what's called substitute. We're going to substitute this in for this, right? So you're going to replace the x in one equation with the value of x in the other. And once we do that, we're able to solve for the place where they intersect. In other words, the y coordinate of the intersection point, okay, of the solution of the system. So let's see what happens. You get negative 7 times whatever x is, which is negative 3y plus 8, minus 6y is equal to 4. And now we're going to just distribute. So negative 7 times negative 3y, negative 7 times positive 8. You get positive 21y. And then negative 7 times positive 8 is negative 56. So take away 56. Minus 6y is equal to 4. You want to combine your like terms. So I see 21y's here, and we're taking away 6y's. How many y's are left? 15y's. So you get 15y minus 56 is equal to 4. You don't want to have the minus 56 on the same side as the y, so you're going to undo minus 56 by adding 56 to both sides, or whatever you do to one side, just do it to the other as well. Maintain the balance of your equation. So 15y is now equal to 60. And you want to undo times by 15 because you don't want the value of 15y's. You want the value of 1y, so divide by 15 both sides of your equation, and you're going to get y is equal to 4. Now, what does that tell you? It tells you that the place where these two lines intersect has a y value of 4. So the ordered pair where they cross is going to be something comma 4. Pick one of these to solve with, the other one to check with. I'm going to use the bottom one to solve. That's when I wrote slow to solve. And the top one to check. Okay? So when we solve this one, we're going to say that x is equal to negative 3 times the quantity of y, which is 4, and then plus 8. Right? So x is going to be equal to negative 12 plus 8, and negative 12 plus 8 is negative 4. So it looks to me like it's going to be the ordered pair negative 4, 4. And now you're just going to check with the other one, right? So we're going to check to make sure that this point is on both lines. So we use this one to solve. We use the other one to check. So this is going to be negative 7 times the value of x, which is negative 4, minus 6 times the value of y, which is 4. And that should be equal to, if we did everything correctly, it should be equal to 4. Let's see if it is. So negative 7 times negative 4 is positive 28. And negative 6 times positive 4 is negative 24. And is 28 take away 24 equal to 4? Yes. So we now know this is correct. So the answer is that when x is negative 4, y should be 4. And that is the ordered pair that is the solution of the system, because it's the ordered pair x and y that exists on both lines. And it's basically the value of x and y that will give you two true statements, one for each of the equations. All right, so that's it. All right, here's the next one. All right, for this one, the two lines we have is negative 5x plus 2y equals 9 and y equals 7x. Once again, they give you the value of either x or y, so that's what you're going to use to help you out. So we know that y is equal to 7x, so just replace y in the other equation with 7x. And then we have everything in terms of x. We can solve for the place where they intersect, the x location of the intersection. In this case here, we're going to substitute that 7x, like we said, in for y on the other equation. So that's called substitution, when you replace one value with another. So we get negative 5x plus 2 times the quantity of y, which is 7x, is equal to 9. You want to then distribute 2 times 7x, or just multiply 2 times 7x. So you get negative 5x plus 14x's is equal to 9. What's negative 5x plus 14x? That's going to be 9x. So when you combine your like terms here, you're going to get 9x is equal to 9. How do you undo times by 9? Divide by 9 both sides, and you can see that x would then be equal to 1. Once you get the x value of 1, we know that the ordered pair 1 comma something, right, when x is 1, is going to be the solution of the system. So now we're going to pick one of these values to solve with, and one of the equations to solve with, and the other one to check with. So I'm going to solve with the bottom one and check with the top one. So in this case, you get y is equal to 7 times 1, which is just 7. So we think the answer is that it's 1 comma 7 as the ordered pair that's the solution of the system. But now we want to make sure we didn't make a silly mistake, so we're going to check it by plugging into the other one. So negative 5 times the quantity of x, which is 1, plus 2 times the quantity of y, which is 7, should be equal to 9. Negative 5 times 1 is negative 5. 2 times 7 is 14. Is negative 5 plus 14 equal to 9? Yes, it is. So now we know this is the correct answer, and we are done. When x is equal to 1, we know that y must be equal to 7, because that is the solution to both of these lines. All right. And that's how you do it with substitution.